This is the AQA Required Practical 5 measuring density. So physics required practical. We are going to be measuring density of 3 different types of objects. We're going to be looking at liquids, regular solids and irregular solids. Now the key part of this required practical is this equation. Density is mass divided by volume. We're going to be using this to calculate the density. So therefore we need to devise an experiment that measures mass and measures volume. Okay, now measuring the mass is pretty straightforward. We can just use a mass balance in most times, but measuring the volume is going to be different for regular solids, irregular solids and liquids. Okay, my results and my conclusions, we want to be thinking about if we have 2 different shaped blocks of aluminium or steel or wood, would we expect them to have the same density or different densities? Does the shape of the material change the density of that material? Okay, that's one of the big parts of this experiment. Relatively speaking, there's not too many hazards in this experiment. The only one really is because we're going to be using water. Any spilt water can cause a trip hazard, and you think about how we can minimize that. So we've got this key equation: density equals mass divided by volume. Okay, now we need to measure the mass and we need to measure the volume. Like I say, we can just place our objects on top of a mass balance and it will tell us how much mass there is. But with the volume, it can be difficult to measure volume. Okay, if we've got a regular solid, it's pretty straightforward. If we've got a liquid, it's quite easy. But irregular objects, it's difficult to measure the volume accurately. There aren't 3 sides to measure. Okay, so we need to come up with a different method for measuring that volume for irregular objects. The other thing we need to be careful about is our units. Now normally in science, for mass we use kilograms and for volume we use meter cubed. Okay, so that will mean our density unit would be kilograms per meter cubed. But because we're looking at quite small objects most of the time in this experiment, we're looking at things that are 5, 10, maybe 100 grams, we would use grams. Okay, and they wouldn't be very big. So we wouldn't use meters cubed, we might use centimeters cubed, which would mean our density units would be grams per centimeters cubed. You need to be familiar with both. Okay, you need to be aware of what units we're using when we're measuring mass and measuring volume. Okay, it's very important. So, first method, we're looking at how to calculate the volume, how to find the mass, to find that amount of density in different regular objects. So the objects you're going to mostly come across in AQA physics are going to be cuboids. And there's a chance you can come up with different shaped objects, in which case they'll give you the equation to find the volume, or they'll explicitly tell you it. But most of the time it will be cuboids. Okay, and it's pretty simple to find the volume. We measure the height, we measure the width, we measure the length, and we times the 3 numbers together to get a volume. Okay, we'll place that object on top of a balance and it will tell us the mass, and we can use those 2 things to calculate the density. Okay, and here's me doing it. So here's my mass balance. Here are the different regular solids I'm looking at. So that's an aluminium block, that's a slightly bigger aluminium block. Okay, I zero the scales, put it on the scales, find that mass, and then I measure the sides. I measure the height, I measure the width, I measure the length. I times those numbers together. And I can do that for each of these different blocks. Okay, I'll record it in the results table, and that's pretty straightforward. Okay, I'm not going to show you me calculating all of these densities and measuring all of these blocks. Okay, but the process is simple. We zero the scales, we measure the mass. We measure the 3 sides, the height, the width, and the length. We times the 3 together, we calculate the density. Okay? Next, also pretty straightforward, is measuring the density of a liquid. So in this case, water. Okay, the benefit of measuring water and liquids is because liquids flow and they take the shape of a container, we can use a measuring cylinder to just directly measure the volume. Okay, so this is a really simple experiment to determine the density of a liquid. So we've got a balance and a measuring cylinder. We pop the cylinder on top of the balance, we put the 0 button on, and then we add some liquid and record the volume. Okay, so we know how much liquid we've added to it, and we know the volume of the liquid because it's in a measuring cylinder. We use those 2 things to find the density. Okay, here's my little method on the side. And I'm not going to read it out, but we can pause that if we need to read some of the detail. Here's me doing it. So here's my scales. It's 0 at the moment, but I'll need to calibrate that. Now in this case, okay, I've got 50 millilitres of water. I know it because my finger's pointing to the meniscus that I've looked at through the side. Okay, so it's at 50 millilitres. I'm going to put that water into a beaker on my measuring cylinder. Okay, so I hit the 0 button, so I know that any mass that I add is going to be that water. Okay, and I drip in as much as I can, and I've got 9.4, and it's going to tick up a little bit, but I've got 9.5 grams, okay, of water that I've added to that beaker. Now you need to be careful that we don't have any extra water left over in that measuring cylinder. That will cause a little bit of error. Okay, but that's how we measure the density of a liquid. Okay, next, the trickier one, measuring the density of an irregular object. For this, we need to use a eureka can. Now, a eureka can or a displacement can lets us find that volume, because we don't have 3 sides on an irregular shape. We can't just, there's no 3 sides to measure. There's hundreds of sides maybe. Okay, so we fill a eureka can or a displacement can with water up until it's at the very top of the spout. Okay, and we place an empty measuring cylinder ready to catch any displaced water. Because when we put in our irregular shaped object into that displacement can, it's going to push the water level up a little bit. And that water is going to flow along through the little spout and into our measuring cylinder. We'll catch that, and that displaced water, that displaced liquid here, is going to be the same volume as the irregular shaped object in the eureka can. Okay, and again, I've got my method here. I'm not going to read it out, but if we want to pause it, we can see some of the detail. And here's me doing it. So my irregular object, a bit of plasticine. There's no 3 sides. Okay, I can't measure those 3 sides to find its volume. So we can put in a eureka can. I'm not going to use the little steel metal one. I'm going to use a plastic one. So I've maybe make that a little bit easier to see. Now notice I've got my finger on the end because I don't want, okay, to lose too much water. It's over full. So I'm going to just put a beaker underneath it to catch this excess water. I'll let the level settle so I don't get too many waves and ripples at the top. It will push out extra bits of water that I don't want. Okay, so I'll let that come to a level. And while that's happening, okay, I'll get ready to measure my plasticine. I'll make sure I'm at 0 on my scales, on my balance. Okay, I've got my measuring cylinder ready to capture. Here's the mass of my plasticine, 98.5 grams. Okay, I'll tip my measuring cylinder just underneath so it can catch the excess water, and as I put in the regular shaped object, a little trickle of water flows into my measuring cylinder. Okay, and I make sure we get as much of that water as possible. Okay, can be a little bit slow if you're doing the experiment. It will dribble in there, and once it finally starts to slow down and only have teeny tiny little drips dripping along. Okay, I think I actually miss a couple now here. But now I can measure that volume on the measuring cylinder, and that volume of displaced water will be the same as the volume of my plasticine. Okay, so here is a results table. Now, if you haven't done the experiment, you can use these as your results. Now, I've left this as a gap for my water and my plasticine because it didn't have a length, width, or height. Okay, now also notice I've got 2 aluminiums. Okay, one was the small block of aluminium that was only 60 centimeters cubed, and one was a larger block of aluminium, which was much bigger, but also much more massive. Okay, so we can copy this table. You can fill in the volumes and the densities if you wish. I'm going to have those completed on the next slide. So here's a point where you can pause the video to calculate those volumes and calculate those densities. Okay. Here are my volumes and my densities. Okay, notice the density of the aluminium block. Okay, they're very similar. I know there's a slight bit of error. They are different. Okay, but within the accuracy of our experiment, okay, they're very close to each other, which is what we expect. If we have pure aluminium, it should have the same density in both cases. Okay, also notice wood. Look at wood's density. It's 0.84. Look at water's density. It's 0.99. It really should be 1. Okay. This is why wood floats in water. It's got a lower density. Okay. So, last little bit is going to be on hazards and errors. As I said at the beginning, the big hazard in this is looking at water spilled. Okay. So, spilled from a displacement can cause slips and falls. To control that, to reduce the chance of that happening, okay, we'll make sure we clean up any spills, and we use containers to catch any excess water that is displaced. Okay, now the biggest error from this experiment is going to be either lost volume in your regular shaped object. So if you notice, some of mine had some chips missing from them, so they weren't perfect cuboids, or not catching all of the water that's displaced from that can, so losing a couple of those drips at the end. Okay, or missing a drip from the measuring cylinder getting tipped into that beaker when I measured the liquid. Okay, so in our books, in our records, we want to have these 4 boxes full. Okay, these are just some hints to get us started, but you want to have a method outlining especially the irregular shaped object's density, how we calculate and measure that. Okay, I'd say that is the most important of the 3 methods, and that's the one I would focus on. You still need to know the density of liquids, that method, and the density for regular shaped objects, but I think this is the trickiest one. This is the hardest one. You wouldn't have come across so much before. Okay, so we want diagrams and we want method here. Key equation. Okay, density equals mass divided by volume. It's hidden up a little bit on my face here, but it's a really important equation. You need to know this, you need to remember it for your exam, and you need to be able to use it. Okay, talk about the units, talk about how we're going to measure those different bits and pieces. Here we can have those results, so we can look at how we can calculate that density using mass and volumes. And then finally, we talk about that hazard of spills causing us to slip and slide, and where that big source of error is from. Okay, so best of luck in answering and filling up these boxes, and another required practical video will be along soon. Bye bye.